So we're going to do some examples of mostly energy problems, but there'll be some momentum problems and some work. There'll be a little bit of work thrown in there too. So in this first problem, we have a 1,000 kilogram car traveling at 10 meters per second, and it collides with another car that's identical to it, and it's at rest. And we want to know how much energy is dissipated in the collision. So the things we need to know are that we have our given is 100 kilograms, and our speed is 10. Our initial speed is 10 meters per second. So we'll start here. We have our given. There we go. Our mass is 1,000 kilogram, and our velocity is 10 meters per second. And we have one car that's traveling this way, and it's going to hit another car that is at rest. This is v equals 0, and afterwards they're going to travel together. They're attached until they stop. So they're going to be going this way, but there is a force acting on them, and they'll slow down and stop. And so what we're looking at is how much energy is dissipated. So the first thing we need to do is we need to use momentum, and so momentum is going to tell us what the velocity is of these cars. We know the velocity of the first car, and we know the velocity of the second car is 0, but we don't know the velocity of the two cars together. So we're going to figure that out. So we'll do P initial, the momentum initial, plus, let's see, oops, see if I can delete that, yeah. Okay, so P initial momentum equals final momentum. And so we know that m1v1 is plus m2v2 is equal to m1 plus v plus m2 v final. And so we know this is 0. So if we want to find v final, then our v final is equal to m1 v1 over m1 plus m2. So our v final is equal to 1,000 kilograms times 10 meters per second divided by 2,000 kilograms and so we have this is equal to 1,000 divided by 2,000 is a half, and a half times 10 is 5 meters per second. So we know our final velocity is 5 meters per second. And now we want to think about, well, how much energy is dissipated? So when this car hit this car and they collided here and they're moving together, they lost energy. And so we can say, okay, K initial is equal to K final plus E dissipated. And so we want to find what this E dissipated is. So we're going to have, this is going to be 1/2 m v initial squared is equal to 1/2 m1 plus m2. Oops. Oh, I lost it all. Okay, so this is 1/2 mv initial squared is equal to, and now our v final are these two cars together, and each of these is m and m. So this is really the total mass for these two cars together was 2m. v final squared is equal to E dissipated. And so just erase this. It'll let me erase. No. So this is actually a plus here. So I'm solving for E dissipated is equal to 1/2 mv initial squared minus 1/2 mv final squared, and so that's equal to 1/2 times 1,000 kilograms times 10 meters per second squared minus 1/2 times 1,000 kilograms times 5 meters per second squared. So that's going to equal, so this is 500, 1,000 divided by 2 is 500 kilograms times 100 meters squared per second squared minus, and this is going to be, again, 500. Oh, and I've lost my, here, this half should be gone. Sorry about that. So this half is gone. So this is actually 1,000 times 25 meters squared per second squared. So here I get 50,000 meters squared per second squared times kilograms minus 25,000 kilogram meter squared per second squared. And so this is equal to 25,000 joules, right? Kilogram times meter squared per second squared is a joule. And so my dissipated is equal to half of my initial energy, 1/2 K initial.